In today's video, we'll be looking at how to use the steam table. So now when we say a steam refers to the vapor or liquid form of water. Now steam is always associated with water. But then steam is like a state of water. So it can be in either the vapor form, the liquid form, or a combination of both vapor and then liquid. So that's what we are calling as steam. So now we have forms of steam. We have superheated. We have saturated, and then we have the subcooled steam. Now, the whole idea of the steam table is that the steam table is to guide us to know some of the properties or the quantities associated with the steam. So properties like enthalpy, entropy, internal energy. We can use the steam table to read if the system you are working with is either water or steam. Aside that, the steam table isn't relevant. So when you are working with air, we can't go and read from the steam table. So now, to know whether a steam is superheated, saturated, or subcooled, then we have to resort to the pressure temperature diagram. So now, this portion, there is one other portion that is called T saturated, or let's call it saturated region. And then this portion is called superheated. I mean the whole of this portion, superheated. And then the whole of this portion is called subcooled. So now, how do you interpret this? It means that when anytime you have a steam, right, and then the steam is coming at a certain pressure. So let's say a steam at a certain pressure P. So at this pressure, we are going to use the steam table to read the saturated temperature of the steam at that particular pressure it's coming with. So we are going to read our Tsat, our saturated temperature, and that's called the Tsat. The moment we read our Tsat, the steam which is coming is actually coming at a certain pressure P and then at a certain temperature T, which might not be equal to the Tsat, right? So the whole idea is that we're going to use the steam table to read the Tsat of the steam at this particular temperature. Now, when we get our Tsat, and then we realize that the temperature of the steam is actually higher than the Tsat, then it falls in this region, and then we say that it is superheated steam. When the temperature of the steam is actually lower than the Tsat, then we say that it's compressed or subcooled. So compressed or subcooled steam. Now, when the temperature of the steam is almost equal to the Tsat or even equal to the Tsat, then we see that the steam is saturated. And that's how we get subcooled, saturated, and then superheated. Now, let's come back to the saturated. So now when we say saturated, what does it mean? It means that the steam actually consists of both vapor and then liquid, right? So if you have a steam in this pipeline, we see that it consists of both vapor, but then there are liquid droplets in the steam, right? So now we have a term we call as quality. So the quality here is the percentage of vapor in the steam. So the percentage of vapor in the steam is what we call quality. So now when we see that a steam has a quality of 90%, then it means that if we have a steam flowing at 100 kilogram per hour, that means 90% of that is actually vapor, right? Now let's come back to the properties you can determine using the steam table. Now we can determine, let's just look at enthalpy because the same applies to all of them. So looking at the enthalpy for the saturated part, because you know that the saturated part consists of both vapor and then liquid. So looking at the saturated part, we have from the steam table, we have what you call HF, HG, and then HFG. HF is for liquid, right? Hg is for gas or vapor, and then hfg is actually hg minus hf. So when you want to compute hg minus hf, you don't have to find hg, find hf, and then subtract. You can just read hfg from the steam table. However, if they provide you with a steam table without any hfg, then you can resort to this. You find your hg, find your hf, and then you subtract. Now, because we are seeing that it is saturated, then there's amount of vapor and then amount of liquid in it. Just that the amount of vapor will always be higher than the amount of liquid because it's a steam, right? And it's always at some higher temperatures. So now, when we realize that the steam is actually saturated, but then it's made up of only liquid alone and there is no vapor present, then all the values we are going to read for the steam will be our HF. So even if it is internal energy, I'm going to read UF. If it is volume, I'm going to read VF. Right? And then when you realize that it is saturated, but then we don't have enough information about it, and they didn't tell us the amount of vapor present, then we can assume that it is saturated, but it has a lot of vapor content, hence it is vapor, and then we can read our Hg throughout. I hope you all get it. So now, and then this for the saturated part. Now let's go to the superheated. So with the superheated, the steam table has been divided into three main sections. We have the saturated, superheated, and then the subcooled. The saturated is what we've looked at. Now when it comes to the superheated, that's what I was saying, that if the temperature of the steam is higher than the Tsat of the steam, then it is superheated. Right? Now when it is superheated, we just go to the superheated portion of the steam table. Now in the superheated, the whole idea is that the whole of the steam is vapor, so there's no liquid present. With the superheated, you're just going to see values like properties like H, V, U. So it's not differentiated like Hg or Hf, no, because it's superheated, right? So you just go there and then read the enthalpy straight, and then you are good to go. The same applies to the subcooled. The subcooled means that it's in a liquid state. So we just go to the subcooled part and then you just read your values. So we'll be working mostly with the saturated because that's what looks complicated. Now when you want to find the quality, so the quality is mostly represented by X. We want to look for the amount of vapor present in the steam. So the quality is equal to the enthalpy of the steam minus the enthalpy in the liquid state all over Hg minus Hf. So we can say H minus Hf all over Hfg. So this is how we compute the quality from the enthalpy. If it is internal energy, it's still the same thing. U minus Uf all over Ufg. So now when we have a steam, and then we know that the steam is like 80% vapor, right? Because now we know that the steam is 80% vapor, when we want to read the properties of the steam, we can't just go to the steam table and then go and read Hg, right? Because now we know that it's not purely vapor and then it's not purely liquid. Now we get our quality. So we just equate 0.82 U. So U becomes the actual internal energy of the steam you want. If it is enthalpy, it becomes the actual enthalpy we want minus Hf. So the enthalpy in the liquid state at that particular pressure, right? And divide by Hg minus Hf or Hfg. This. So we multiply this by the 0.8. We add our Hf to it, and then we get our enthalpy of the steam. That gives us the actual enthalpy of the steam. So I have some few questions here that I want us to go through. Now the first question is, use steam tables to determine the temperature, specific internal energy, and the specific enthalpy of saturated steam at the river. Now one important thing is that the steam table provides us with information which are already specific. So you always see enthalpy in the form of kilojoules per kilogram, as well as internal energy, kilojoules per kilogram. So like they are all specific, right? So we go to the steam table and then let's look at the question. Use steam tables in appendix to determine the temperature, specific internal energy, and specific enthalpy of saturated steam at 3 bar. Now, the question has already given us an idea that what we are dealing with is actually a saturated steam. So we open our steam table, right? Realize that the steam table has saturated parts. So this is what I was referring to. You have the saturated part here. So you just move on to your 3 bar. Right? You move on to your 3 bar. So at 3 bar, the temperature is 133.5. So 133.5. And that is our Tsat. You can see it here. Ts is Tsat. So Ts is equal to Tsat. So at that 3 bar, you get our temperature at Tsat to be 133.5. Now, if you had known the temperature of the steam at that 3 bar, then we can say that if it is greater than this, then superheated. If it is lower than this, then it is subcooled. If it is equal to this, then it's saturated. But now, because the question didn't give us the temperature, and the question says that the steam is saturated. That's what the question says. The question says the steam is saturated. And when I say it is saturated, then we know that the temperature is equal to the Tsat. Right? So that means the temperature is equal to our Tsat. So the temperature of the steam will now be our 133.5. Now we are supposed to find specific enthalpy. Now because it's saturated and then we don't have the quality, then we can say that our enthalpy will then be 2725. That is for the Hg. And then our internal energy now becomes Ug to 2544. Yes. So if you want to find entropy 2, we are going to use 6.993. Now let's get back to the next question. The next question says that what is the state of the steam at 10 bar pressure and 400 degrees Celsius? Now we have another steam which is coming at 10 bar and the temperature is 400. So we go to our steam table. So at 10 bar, this is at 10 bar, and at Tsat, so at 10 bar, our Tsat is equal to 179.9 degrees Celsius. And now, but the steam was coming at a temperature of 400 degrees Celsius, which is actually greater than the Tsat, so it is superheated. Right? So we come back to this and see that when we compare this, Tsat was 179.9, and then the actual temperature is around this portion, which is greater than the Tsat, so it is superheated. So the state of the steam is, so the first one, the temperature is 133.5 degrees Celsius. And then the second one is superheated. This is how we read the steam table. Now, what's the essence of the steam table in application to the first of thermodynamics? Now, because steam flows at a rate, anytime you see a steam, you're actually referring to open system, right? And then we know the first law of thermodynamics for an open system. So K minus Ws is equal to change in enthalpy. So let's neglect the other factors. Now, when you have the OP system in this way, at this point and at this point, when you want to find the change in enthalpy, it's H2, H1, which is actually H2 minus H1. So now, the steam entering, so when you have a steam, the steam entering will be entering at a certain temperature and at a certain pressure. So we are going to use that temperature and pressure to evaluate our H1. And then when it's coming out, it's also going to leave at a certain temperature and a certain pressure. And I'm going to use that temperature and pressure to also evaluate our H2. And then we can find the difference between them, and that will be our change in enthalpy here. Sometimes the steam engine will have a quality. It means that it is saturated, but then it has a certain amount of vapor and a certain amount of liquid. Now that you have a certain amount of vapor and a certain amount of liquid, if you want to find the enthalpy of that steam coming, we can't just use the temperature and pressure to read the values from the table. So what we are going to do is that we are going to equate the quality we have to H minus HF all over HFG. So at that pressure, so one thing you should also take note is that anytime you've been provided with quality, it means that it is saturated. It can be superheated or subcooled. So at that temperature, you are going to read our HF. So at that pressure, you are going to read our HF and then read our HFG. And then we can equate it to our quality. And then we find our H. And that H will give us the actual enthalpy of the steam. Sometimes you can be given the enthalpy of the steam and they can be given the pressure and then you'll be told that it is saturated. In that case, the question will ask you to find the quality. And let's have to find your HF, HFG, you subtract and divide and you find your quality. I think our next video will be solving more questions on that. So now we are done with the first law of thermodynamics in relation to closed system and then open system. So for our next two videos, we'll just be solving questions on either steam tables or just normal gas systems we know. That'll be all for now.